Go. Okay, everybody, thanks for coming to a homebrew night. We have, I think, 10 signups. We had a cancellation, but then Andy filled that spot last minute. So I'm going to give you the order. Hopefully this works for everybody. First up will be Ben, Justin, Connie, Tony, Andy, Mikko, Shri, Sorin, Paul, and I'm thinking I heard Masa was on Zoom. Is that correct? Okay.
Yep.
All right. Was there anybody? I think everybody else. So without further ado, we're going to get this going, and Ben, you're up.
Hi, everyone. So I want to put everyone in a scenario that you may have been in before. For some reason that may or may not be related to your employment, you found a time where you got a really great deal on a super power hungry GPU. And and then you looked at your PC and the power supply. Oh, can you switch? Thank you. No, the overhead. It said this number 750 on it, but you did some math that said that you needed about maybe 1200, 1300, which is almost double of what this thing can supply. So you go to Micro Center and you buy a nice 1300, 1400 watt power supply. You bring it home, you put it in your PC, and you have this thing lying around. And then you remember that a lot of the equipment that you use for your other expensive hobby uses similar voltages to the one that this thing can produce, but it has this one has these silly connectors, right? They look like this. It's not very useful. I can't stick a wire into this and then put it into the radio. And the other thing you notice is that this number, which you probably can't read here, but it's the number next to the plus 12 volts, and it says 62.4 amps. And that's a lot of amps, and you could use those amps to do something, right? But again, the plug doesn't work, and it's 12 volts. It's not 14 volts, and so what you do is you imagine that you want some power poles on basically going directly into this. So that's what I built. It is ignore the lack of power poles. I'll get to that in a moment. Hang on. So this is a board that will. These are it's really funny. These plastic pieces. They will mate with all these Molex. This is a Molex Mini. What is it? Mini Fit Junior is the name of the product line. They will mate with the Mini Fit Junior, but the data sheet says they don't, because I guess there's some patent situation going on there where they're not allowed to, but they do. They mate just fine. So if you ever order DLL 5566 dash either 24, 8, or 6, just know they are exactly what you want. The data sheet is wrong, but they're exactly what you want. So it goes from there. I have exactly one control. It's a switch, which shorts the pins, I think 14 and 16, which is the power ready signal. I've got an LED that you flip the switch that shorts the on signal. Internally, the controller in this thing will then bring up all the power rails. The light will turn on if the power OK signal is asserted. And then I've got everything fused. This is just a whole bunch of fuses. I bought 25 amp fuses for one reason, which is that they were on sale. So these were $3 for 10 of them. I've got some screw terminals, and then I've got some holes that look like about the right size and shape for power poles. And the reason that they're holes and not power poles is that I somehow designed this for the one variant of a right angle power pole that is never in stock. So there's 4 lengths of these power poles where it goes from here and down to here. You put the little piece of plastic on top, and then you solder it in. And the length that I cut the board to, which is the length that was just most convenient for me, is the one that there are 0 in stock in the entire country. So I just told them to build it without them, and then at some point I'll plug them in. So until then, I have to just use the screw terminal. But yeah, that's pretty much all it is. So now I have a 62.5 amp power supply. Yeah, go ahead. Yes. Yeah, Connie. Oh, I think it's you.
We have
Stand by.
the
Okay,
Matrix.
go ahead.
Yeah. Who built the board?
JLC PCB.
JLC PCB.
Yes. No comment. The question was, how was the shipping and other things that the shipping bill includes? And I said, no comment. I think Alice had a question.
If you want to build one, how do you get all the antennas in stock?
You mean the power poles?
Yeah.
All the parts. So they have if you design it with parts that are made by some manufacturer that they know about, or some retailer, so that are sold by some retailer that they know about, you just kind of click a button on their website, and then it tell them, this part goes here, this part goes here, and there's a way to design the board so that it'll fit correctly. Yeah.
Thank you. Justin, you're up.
All right, simplest homebrew project that I've brought so far. This is an antenna for satellite communications. By appearance, it's cut for 2 meters, but in my haste to get here, I actually put the 2-meter elements on a board labeled 70 centimeter. So I have half of each of those antennas to show you today, rather than one or the other. But this is a kit build from Halibut Electronics, and you might remember the massive complex Yetis that I built last year. This has a few advantages over that. It's a lot smaller. It's a lot easier to put together. There's 4 nuts on the elements right here, and that's it. You put those on, you tighten them down, and it's from flat pack to antenna in about 5 minutes. It has another distinct advantage which is that it works compared to the last one. It is less pointy. It has less forward gain. It is also not always circularly polarized. So it's circularly polarized except when the satellite's on the horizon. When the satellite's on the horizon, it's linearly polarized. And then as it comes up over the horizon, it becomes circularly polarized. So if you're not matching polarization as the satellite comes up on the horizon, you've got a few minutes where it doesn't work, even though you can see the darn satellite. Which is fine, because this has, again, the advantage that you don't have to point it. So yes, I have about 10 dB less forward gain, but forward gain was never the problem. It was hearing the thing in the first place and having an SWR below 200. This has an SWR below 1.7-ish across the entire. Yeah, about 100 times better. It's about 1.7 is the worst across the band. And they're both cut specifically for the satellite portion of the band. So on 70 centimeter side, you only have one satellite band to deal with. So you've got 435 to 438. And it's below 1.2 across that entirely. And then on the 2-meter band, you've got a couple that are spread apart. And I think the worst is like 1.3, something like that. It's very well matched. I have a couple of questions and I don't have anything else to say, so I'm happy to take them.
So since it's circular polarized, doesn't matter how you orient it when you're getting the satellite?
Correct. It doesn't need to be oriented. It doesn't need to be pointed. The mounting cap here is 2-inch PVC. So the entire deployment procedure is to stick this on a PVC pipe and then just wait for the satellite to come to you.
Well, that makes it very convenient when you get your UHF one for the upside or downside, whatever. Then you don't have to worry about the orientation either one. That's great.
Correct. 2 different pieces of PVC. And I have both the 2-meter and the 70 centimeter built and tested. This behaves very badly because it's the elements of 2-meter and the phasing match for 70 centimeter. But now I want to go stick it on an analyzer. Mark and Connie both had hands up at some point.
Well, I have the mic, so I'll ask first. Yeah. So the guts of this are a kit, you said, but you put it into the cap. Is that correct? And it looks like the elements are homebrew as well.
Yeah, so you provide the elements here, and everything else is in the kit. So the cap, all the hardware, and we can switch to this camera. I can show you the boards. Yeah, whichever Rob wants. Yeah, so there's a phasing board here, which is by frequency. It's got a little balun on it, and your choice of connector, and then that fits at a right angle into another circuit board, which is actually holding the elements. So that's all a kit from Halibut, and it's inexpensive and easy, and you just cut the elements that you want and tune it.
Halibut. Okay, excellent. Thank you, Justin.
Actually answered my question. I was wondering what was on the board. And so it's just phasing to get it circularly polarized. Just
correct. So yeah, there's a 90-degree, there's a transmission line on the inner layers of the board to get you your 90-degree phase shift. And then there's the balun, and that's the entire board. There's nothing on it.
And there is a little bit of gain in the out direction. It's circularly polarizing the out direction, but it sounds like your plan for the next field day is just to leave them fixed, not try and articulate them.
Correct.
Okay.
The difference in gain between horizontal and vertical is less than 3 dB. Now, if you're out of polarization match at the horizon, then you've got that problem to deal with. But the crossover point is somewhere around 15 degrees above the horizon. So at 15 degrees above the horizon, it's very close to circularly polarized, and your worst mismatch is a couple of dB. And who cares? So if we happen to roll the dice badly and we miss the first couple minutes of a satellite pass, I don't care. We missed all of the minutes of all of the satellite passes last time by not having a working antenna, except for one. Yeah, exactly. Shri in the back.
Yeah. I just love to see a version of this where you replace those with nichrome, like we saw that Yagi last week, and then you flip it over, stuff it in your 2-inch PVC, and take it up to a summit and pop it out and have it spring open, and then do your satellites.
Nice. Yeah, this is the bring your own elements. This is 10 gauge Romex, because it was stiff enough that it would hold up at this size, and I had some. So that's the decision there. You can go with lighter gauge for the UHF version, but I didn't have any, so it's 10 gauge too.
So the next field day, what would you do with your soldering iron?
Next field day, I'm not bringing out any soldering irons. Everybody can keep theirs at home, or somebody else can have a disaster and need help. Someone else can have the car accident next year. Not me, not Doug. Save difference. All right, that's it.
So I guess you did it for the hell of it, right? Wah, 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 wah.
Also, I'm terrible with names, so I don't remember the guy's name, but the guy who does all the designs for Halibut's a great guy, so go read his website. He's got some cool stuff coming.
That's perfect.
Hi, I'm Connie, W6EFI. How do you make it big? Okay. Yeah. My radio is a Yazoo FTDX10, and it doesn't have enough buttons and knobs. So my homebrew is add more buttons and knobs, solve that problem. And last year, I've actually been thinking about this for a while in between all the other things that I do. Last year, I actually, at homebrew night, I came in with this guy. Oh, very good. Okay, except that my face is obscured by this thing. So people want to see my face, no doubt. So that's just a number pad, just an ordinary bog standard number pad. And I tried binding some keys to some cat commands. Well, that kind of worked, except that it has limited capability for customization, and not everything I want to do with buttons and knobs can be handled with simply rebinding keys on a keypad or even on a keyboard. So this year I have the real thing, which is a QMK, quantum mechanic keyboard, open firmware, customizable, programmable macro pad, which now has the minimum functions that I want on buttons and knobs that I don't want to have to dig through menus to get to. This is for CW operation particularly. I have one button that turns keyer on and off, so I can switch between paddle and straight key with just a button click. It allows me to toggle between break-in on and off. Break-in is whether or not you're actually transmitting with your key or not. That's useful because I want to be able to match the other person's speed without transmitting first, and then I come back in and I can transmit with my paddle. And then I have a knob that is just the speed control right now. It's programmed to be speed control, and then I had an extra key, so I just tell it I want speed 18. So that's it. It involves slightly customizing the firmware on the macro pad, which is easy to do. QMK is designed to be easy to do that. And I also run a process, a daemon on the computer. And I'll explain why I can't just do it with key bindings and macros and scripts offline, but it doesn't work. So I'm actually running a program on the computer. That program lives happily alongside WSJTX and QSSTV and FLDigi and all the rest of them. Yeah, so that's it. Okay, Mike. Okay, Andy, I'll get to you after Ben.
Have you ever considered or investigated plugging it directly into the radio?
Yes, I have considered it. The radio is expecting a computer plugged into it. So the radio will not accommodate two computers plugged directly into it. So the way I deal with all of the devices that connect to the computer is one USB connection that goes to a hub. So a USB connection to the radio, that's a hub, and the computer plugs into that, everything else plugs into the hub. So this thing doesn't actually plug directly into the radio. I'd love it to. And I have a contest keypad that looks like a little gaming keypad that does plug directly into the computer, and that sits on the desk next to this thing. But this is the way I've got things plugged in with a USB hub. But great question. And there's more to that, but I won't take up time on that. So yeah. Okay, Andy, next.
Well, yeah, my question is, I don't see a knob. Is there a knob? One of those things, or
this is a knob.
Oh, okay, all right.
Here.
All right, Daryl has a question. I have one.
Yeah, I could do that. And next year I'm going to come back with a larger one that's got more knobs and bigger knobs.
Yep.
And
Nice.
I'm taking requests for colors too, because those keys, those key switches, those keycaps are swappable. Everything is hot swappable on that thing except for the rotary encoder, which I had to solder on. Yes,
Connie.
Tony.
Daryl.
Who's got the mic?
I do.
Hi, Daryl. Yeah.
So what you're doing is you have the program running,
and you're sending cat commands to a COM port that the radio then gets, right? Or are you sending it through CV or CIV
It's cat commands.
to CIV?
Well, it's Yazoo radio, so it's just
Okay,
to a
but-
COM
but-
port, to essentially COM port. It's a TTY.
Oh, okay. Oh,
Yeah.
it's a TT1.
Yeah, it's a serial. It looks like a serial terminal.
Are you on
like
a Mac or
serial
Win-
device? I am on Linux.
Oh, there you go.
Yeah.
Okay, that's why. All right. Okay,
Yeah, but it
that
should
makes
work.
sense.
It should, the principle will work on other
Right.
computers, and then there are other ways to do it with HamLib or FLRig, or there's lots of different ways to implement this. Really, the takeaway is that this can be done. You do not have to spend $400 for a commercial product
Right.
to do this.
So what you're doing is you're listening for the key, the actual keys,
That's correct.
and then you're translating that into the commands for the radio.
That's correct.
That's pretty straightforward.
Yeah, very straightforward. Go do it. And you don't even need to use macro pad. You can use a real keyboard, as long as it's, you have some programmability. Yeah. So I see this more of as proof of concept that works for me, and hopefully enables you to go and do. And I think Tony had a question.
I mean, could you say any more about what that interface layers look like? Like, how are you interfacing a rotary encoder to something that's encoding that as a keyboard command?
The rotary encoder is a fancy word. It looks just like a bunch of key presses, right? So if you click in one direction, it looks like I could be just adding an up and down key, instead of a knob. So it clicks when you turn it, and you turn it one way, it click, 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 and it looks like an up click. So it sends key code 193 or something. I think it's 197. And then you turn it in the other direction, click, 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 click. It's sending key code 198. So that's all there is to it. Yeah. One more question? And I'll be here, folks, all night. So
It's a quick question.
Yes.
Did you use AI, and if so, what tool?
I did not use. I used AI I asked AI how to demonize my program. So, because I didn't want to figure all that crap out. And I asked AI. So when I use AI, I'm basically asking it to search documentation, for programming. I don't really use it for much other than that. Sort of, all right, oh gosh, I need to trap this interrupt. How do I do that? Oh, AI comes back and says, hey, dumbass, use set jump. And it's like, okay, yeah, that's right. I remember that. Yeah. So, and I think I don't even remember. It might have just been like DuckDuckGo's stock AI. I mean, I was searching for documentation on stuff. Yeah. Oh, is there? I don't know. It's like, yeah. So it's like, it's something that's pretty common and known how to do, but I don't do it much. I don't want to spend 2 weeks figuring it out. Just give me a code snippet. So when I use quote AI, I'm doing that instead of going to one of the Swiss Army knife code snippet sites. But yeah, I mean, this is really straightforward. It doesn't even need all that much intelligence. So just my artificial stupidity here. It's like, I like to operate CW, and I want to be able to move around really fast with those controls. So stay tuned. Next time there'll be bigger knobs, more knobs. There'll be a power knob, etc. So, all right. Yeah. W6EFI, Connie. Thanks.
Great. So this is a project that was inspired actually by John N6 Yankee Uniform, talking about walking around with a Nano SA, measuring antenna patterns. And then she won, I guess, the elk antenna. Okay, yeah, she then won the elk antenna, and so I kind of was interested in what kind of stuff could we do, and you know, I have a nano VNA, but I kind of wanted to see, you know, an SDR looks a lot like a nano SA if you actually think about it. And so this was kind of a play project to figure out how can we, you know, do direction finding, do some, you know, antenna pattern identification for handheld antennas, you know, using an SDR and actually like a Pico Fox, for example, which I put in the back of the room as an RF source.
So we started out by using a normal compass for radio direction finding. We found that it was not that accurate. And the reason was because the compass could not sense the orientation, so it was inaccurate. And when it was facing the magnetic poles, it went crazy and very inaccurate. And so me and my dad figured out that using an accelerometer helped detect gravity. So telling the compass what side is down, what side is up, and what your orientation is. And it made it much more accurate in a way that it's much easier to do radio direction finding and finding out the orientation of your project when you're trying to find a fox or find another station.
And so, if any of you have ever played with this, there's some really cool interfaces which I really wanted to learn a little more about. You know, the guts inside of an SDR and how to work with them. So this is GNU Radio, and it's a little bit of a pain to get the RSPDXs working with it. I think due to license issues. But anyway, you can very easily draw block diagrams, rearrange them, play with them. So, you know, we have our radio, and then you know, in this case, for example, we just have a little spectrum analyzer coming out of the radio that shows us a local frequency band. You can very easily put up controls that'll set your frequency, set your attenuation on the radio. And then to calculate the power, which is what we're interested in for the antenna measurement, is you can just put a filter in. So we did a low pass filter, and then you just take the log magnitude. So you can just square it, take the magnitude, and then you have a number, which is the power in your antenna. And then what's cool is, you know, we can, for example, we just take that and you can display it really easily. You drop a widget in, but you can easily build in Python programs. So we did use AI to, you know, in this case, this is a little IMU unit, which has a compass and accelerometer in it. And you ask AI, can you make me a Python driver for this device? And it goes out and it reads the data sheet and it finds other drivers, and you have a driver and you don't have to write it. It's great, works super well. But then you can very easily pull together your Python. You can make Python plots, and all of it just kind of comes together very easily for you. And so if you ever want to prototype, I don't know, this was super cool, super easy, super fast to do. And I think we have enough time that we can just do a quick demo of how this guy works. I may have to share again. Yes, sorry about that. Do the honors. So this is that UI, and so all we're gonna do. So this is the Pico Fox signal from the back of the room. We just are gonna set our reference orientation, and then we're gonna go ahead and we'll start capture. Oh, and okay, so go ahead and you can rotate to 360. And I'm gonna stop sharing while she'll go ahead and do this. We'll get an antenna pattern. I should have shared my entire screen. There we go. And so we've got something that looks very much like there we go. So we have our very much cardioid pattern with the pattern that's been slightly distorted by the presence of the magnetometer. But so very easily you can just map out your space. And of course, the next steps for this are to add the GPS module in so that you can then move around, take these coordinates, do your maps, and then triangulate. And I really want to do this for local noise sources. There's a lot of noise that shows up at my house. And so I want to just go around. And the nice thing about this SDR is it'll take a 10 megahertz slice of bandwidth. And so I can find all the noise in 10 megahertz. And then I can triangulate those locations. Hopefully, we'll see how well the signal processing actually works in real life. And also Fox Honey, of course, is an application. So any questions about this?
I've got a quick question real quick. So it looks like spaghetti right now, but if you put this all out, you've just got, what's in the lumen? Just 2 cords? Okay. and then the coax. Okay. Perfect.
Were you planning on taking the stuff that you get from the direction finding and putting it onto a GIS or something like that to map this out?
The next step. Oh, yeah, that's absolutely the next step. And one thing I'll say, for example, is, you know, I played with QGIS, which you haven't played with it, by the way, is awesome. And you can like download laser dems, and we use that for summits on the air and like route planning up mountains because it'll see through the full. It's like incredibly cool. But yeah, so for example, I plan to use AI to just use, you know, Leaflet, for example, to just do local mapping of this stuff, which I don't really want to learn the interface necessarily. And AI has been really good at pulling this kind of data, dumping it into Leaflet so you can visualize it easily. So that's my plan to do that.
Yeah, Tony, this is a really incredible system integration project. But tell me, in terms of calibration, how does this project stand up relative to most advanced fox hunting technology? Because with this, you can actually triangulate and eventually get exactly where the location, the pinpoint is.
I mean, I haven't tried it for that yet. I'm going to say it's the best thing. It's going to beat all the technologies. I mean, I'm pretty sure that's also a very nice radio direction finding system is my guess. I'm guessing that's one of these okay, anyway, I can't wait to hear about that one. I mean, I will say the calibration and like multipath. I mean, you can see, for example, so this measurement, I have done it at home as well, a very similar setup. And we actually gotten the cardioid pattern, right? Or the full, the two lobes, for example, with two nulls. But, you know, again, I think we're probably seeing some multipath in the bodies. So I think when you actually try to run this in real life, you're going to start running into all the issues every fox hunter runs into with actually getting accurate RDF out of it.
Question. Have you gone to any of the Fremont second Saturday hunts with that?
We would no. Well, this is pretty new. I'm looking forward to doing that kind of stuff. I will say, like, for example, this antenna is quite low sensitivity. I mean, it's actually not bad on 2 meters. So, you know, we're going to have multiple antennas. And then for it's an inversion problem, right? When you're doing the RDF with it. And so then you need to know your antenna pattern as an input to the problem. And of course, then you know, the body effects are going to be part of an issue with that. But yeah, I mean, that's kind of where we would like to go with this project eventually.
Please be sure to bring that to the PAARA field day in the park for the hunt.
Yeah, absolutely.
Okay. Thank you so much. That was great. Oh, okay, Andy, you are now up. And I presume you don't need to use the screen, right? You're not presenting anything?
He has a picture that he wants.
Oh, a picture. Okay.
This is a Doppler direction finding antenna, and there's a little antenna switching circuit here, and this DB9 is connects to my old Ramsey Electronics DDF1, and it also I made my Raspberry Pi direction finder use the same compatible connector, so it switches. So the DDF1, Ramsey Electronics, which is now unobtainium, it cost me $150 for the kit 25 years ago. Now there's nothing like that available. So I'm working on the Raspberry Pi version. I didn't bring it here. But anyway, this will be mobile. You see these two legs here, PVC. That's going to be on top of my car, and then there's a 1,200-pound strap I use to hold it down. Okay, so that's what I'm going to use for fox hunting once I get it to work properly. You see that one element here is just kind of taped together, dangling. I'm trying to fix it, but I've been too busy with the software on the Raspberry Pi to really finish it. So it did work once, but it was getting wrong bearings. And I think it's because the toroids I used, I wired one of them backwards. Primary. Anyway, okay, now, Ben, can you show the other one, which okay, now that one I just finished today building it, and it has 12 dipoles, and there's nothing connected yet. but I'm going to have to buy lots of balance toroids, and I only got 6 so far. Anyway, by the way, where you can get all these parts in Santa Clara is Anchor Electronics. Okay, so this is going to have three boards like this, antenna switching boards, and a Raspberry Pi will be switching one set of verticals in one core of the Raspberry Pi 3B. Another core will be it's switching one horizontal array. The other one will be switching the other horizontal array. So this will allow me to actually get not only bearings to satellite amateur satellites, because you might ask, why do you want to do that? The Kepler coordinates are online, right? Well, because I can. It's like, why? It's like you ask somebody that goes up to Mount Everest, why do you do that? Because it's there, right? So anyway, but no, furthermore, it'll tell me the polarization of the, and Sorin wrote me a beautiful, KN6YUH, wrote me a beautiful program to go mobile with this antenna. And it makes your Raspberry Pi become a web server and access point. I'm not into IPs, but these guys, Shri helped me with, a lot of guys here helped me. And so I was going to buy a little interface and start connecting stuff to Raspberry Pi to show bearings. And I think it was Shri or somebody said, well, why do you bother doing it? Just make your Raspberry Pi an access point and web server and on any device. By the way, when I get it all working, I plan to go to the Fremont Fox Hunt. And when I arrive there, I'm going to say to all the guys, hey, you guys want to see my bearings? Turn on your phones. And it's a very simple, beautiful program written by Sorin. So, but for this antenna, if Sorin can't do it, then I'll try to do it myself. I'm gonna have his program shows little circles that slowly float, and you can adjust how slowly they float towards the center of a compass rose. Well, by the way, that's one feature that his program provides for me, is that I can actually see bearings, multiple bearings, multipath, with these circles floating towards the center. But I'm going to ask him, but if he can't do it, or somebody else maybe can help me, how to draw little fighter airplanes, delta wing airplanes. And so there'll be, instead of circles flowing to the center, there's going to be all these little fighter planes, and a pitch, yaw, and everything, give us the polarization. Anyway, I have to just write the software to handle that. Looking forward to it.
Question. You want to take the mic to Tony? Tony. Yeah, I think Tony's got a question.
I guess just a first thing, if you wouldn't mind explaining what Doppler DF is, because not everybody necessarily knows. And then I'm also curious.
Doppler DF has been around for many years, and what it does is when you switch between antennas, there's a Doppler effect when you switch from, let's say I switch clockwise. I have antenna 1, 2, 3, 4. Well, when you switch from 1 to 2, there's no effect. But when you go from this to here, back of you, then suddenly the frequency apparently gets lower momentarily. It's so, and sideways there's nothing, but then suddenly the frequency gets higher. And so the phase detection of your FM receiver creates a tone, and you have to detect the phase of that tone relative to the synchronization sync pulse, which is based on how you switch the antennas. It's called a Doppler direction finder, and it's been around for a long time.
And I guess the second question is, so when you're doing the sort of 3 orthogonal arrays, are you running them just at different frequencies and then running your PLL at different frequencies, or are they actually running separate channels?
It's not a PLL. Some of my friends recommended that I do a PLL, but I did it my own way. I FIR filter, finite impulse response, 311 taps, but very narrow band filter, and boy, it really picks off that tone in 1/20th of a second. I can capture chunks. If a signal is very strong, in 1/20th of a second, I get a bearing. But of course, as the signals get weaker, then you have to integrate over time. And now with the three, is that enough? Or,
I was just gonna ask with the three. I mean, are you running separate receivers, or are you just doing three separate tones and with three separate?
Okay,
reasons?
actually, my first plan is to have the Raspberry Pi, but it's going to be running the same filter. I don't need three tones. Maybe I will. I'll see. But for 1/3 of the time, the Raspberry Pi will grab with a stereo sound card, which gets sync pulse and the audio from radio. It'll store 1/3 of the buffer in one core, send it by files, Linux files, to I guess to a fourth task that does all the processing. And so each one of these, one takes this, one takes that, one takes the other. And so those buffers will be handled in the fourth core, which will then together process everything.
Hurry.
Would there be any benefit to using a GPU to process all these signals?
I hear it's kind of bad.
GPU, would it be better to use a GPU to process the signal?
Oh yeah, I don't know how to do that yet. But a Raspberry Pi is, but our Raspberry Pi is so fast at 2.5 gigahertz clock. Is that right? So, yeah.
On the model.
Okay, I have Pi 3B, and so I can do this very long filter, narrowband filter, in 1/20th of a second. You know that the Kraken system that actually isn't Doppler, Kraken. It started out at $300 at crowdsource. Then it went up to 400. Now it's 500. I think this whole thing that I'm making will be well under 200. I thought it would be under 100, but you know, with all the tariffs and everything, it's all getting more expensive. But I'm sure I can be under $200 for a Doppler DF finder, and the Kraken system cannot get your chunks, but I can.
All right. Thank you, Andy.
Andy, you want help with a GPU, let me know.
Okay, Mikko is up. While Mikko's coming up, I do have an interesting story about Andy and his legacy of RDF. Years ago, one evening, there was a repeater stuck open, and him and Rachel, KK6DAC, got in the car and they started DFing this signal. It was at night, and they ended up in Berkeley or Oakland. And they were in the neighborhood, and I used QRZ to cross-reference the possible addresses, and I got a match of a ham listed. I emailed. They did not knock because they didn't want to get shot. And it turns out the guy emailed me back and said his cat hit the transmitter or something, and he apologized.
All right. So, quick project. I'm following in the footsteps of Justin. This is the simplest thing I've ever brought here. It's a balun. It's a HF balun. A little bit of background. A lower frequency full wave loop makes a pretty good multi-band antenna on HF. For example, if you make a 40-meter loop, it's resonant also on 20, 15, and 10 meters. But the one catch there is, so that's a good thing. And I actually wanted to build a 40-meter loop for my backyard. It just fits there. And yeah, it can be used also on 20, 15, and 10 meters because those are multiples of the 7 megahertz fundamental frequency. The one catch with that is that on the harmonic frequencies, the feed point impedance is not the same as on the fundamental. So I was simulating the 40-meter loop. I noticed on the fundamental frequency, meaning on 40 meters, the loop feed point impedance about 200 ohms, maybe 150. Depends a lot on the shape of the loop that changes the impedance. But on the harmonics, on the higher bands, yes, it is resonant, but the feed point impedance is different. So it gets really difficult to pick a feed mechanism or how to feed the loop so that it works well on all the bands. And working well means gives you a good match. So, for example, on the fundamental band, 40 meters, a 4-to-1 balun might be ideal. It gives you very good match to 50 ohms. But on the higher band, just a 1-to-1 balun or meaning common mode choke would work better. So how to deal with that? I decided to make a switchable balun. So this thing, I made a little PC board. Of course, it has the toroids on top of that, but at the bottom there's a PC board like that. I used 2 of the 2.4-inch large toroids, mix 43. That's good on the higher bands. The mix 31 is ideal for like 80 meters and 160, but the mix 43 is better on the higher bands. 13 turns there. 13 turns on each toroid. You can kind of see the 2 toroids there. Maybe you can take a look at that for the people who are here in the room. 13 turns on each core. Each core by itself is wound as a 1-to-1 choke, but then depending on how the 2 chokes are connected, it either makes a 4-to-1 balun or 1-to-1 balun. So on the input side, where the coax goes, the 2 toroids are connected in parallel. So hot to hot, cold to cold, and that goes to coax. On the output side, if you connect the 2 toroid outputs also in parallel, it makes a 1-to-1 balun. If you connect them in series, it makes 4-to-1 balun. And then I have a relay there on the output side to change that. And there's the picture of it before I put the lid on. What should I say? So yeah, so you can remotely, so from the shack, I can remotely change the balun. Is it 1-to-1 or 4-to-1 by feeding 12 volts DC on the coax. If the DC is there, it's 4-to-1. If there's no DC, it's 1-to-1. The whole thing is good for about 1 kilowatt on sideband. Less, of course, on digital on those modes. End result, it works pretty good. It gives lower than 2-to-1 SWR on all the bands, including the harmonics. So yeah, works kind of good. Oh, is there more? No, that's it. Simple stuff.
Question.
Yeah, questions.
Price.
There's so boards made by same company, already mentioned JLC PCB, not including the shipping and tariffs. They are super cheap, so probably $5 for the board, the box, the toroids. So I think I have total less than $50 in that. Oh, okay, all right.
So Mikko, when you change it with the relay, sending 12 volts down the coax.
Yeah.
Do you have some sort of a way to switch off the coax feed into the radio when you do that?
How to switch that? I didn't quite.
Okay, so if you got, I presume it's the same coax going into the radio.
Yeah. So there's only one coax going up to the antenna. On the radio end, of course, you have to have what's called bias T. So you can feed 12 volts DC into your, regular coax. So you put 12 volts on the center pin of your coax.
Right, but you don't want it to come back into the radio itself.
Right, and that's the job of the bias T.
Okay.
So the
okay.
bias T has a DC blocking capacitor
Oh, got it.
going towards the radio, and a small DC or RF choke that then again feeds DC into the coax, but blocks the RF going into your power supply.
One last question. Is this similar? Have you seen the buddy pole what they call the tri-setting balance? They got 4-to-1, 2-to-1, and 1-to-1.
I haven't seen that, but I know there are balance where you can use like jumpers.
Yeah.
You can hook it up differently when you are connecting the wires, and then it gives you different impedance ratio.
Cool. Awesome job.
Cool.
Andy's next, and then Shri.
Well, I think my question was about other ratios, like 13-to-1, 3.5-to-5, and things like that.
Mm-hmm.
The last thing you said sounds like you already can do that. Yeah.
So
if not, I was going to say, I've seen online many complicated connections of multiple winding toroids, so we can get any ratio you want.
If not all ratios are possible. That has to be said first. Using more like auto transformers, which is really a transformer instead of a transmission line balun, two different things. With RF transformers, you can create more of these odd impedance ratios, like all the end-fed half waves. Most end-fed half waves use the 49-to-1. So that's a turn ratio of 2 to, I can't remember, 4, So, yes. And then, but not all ratios are possible. But with complicated sort of, call it architectures, you can make like 2.5-to-1, like that. 4-to-1 is super easy. So, yeah.
So in place of where you have the relay, could you put a resonant circuit such that it is simultaneously a 4:1 and a 1:1 balun at the same time?
I guess you could. You could put like a detector there, and if you see, it could automatically, pick. Well, it could be that. I would do the automatically pick. So sort of voltage detection. So high SWR creates the peak voltage. If it exceeds something, switch to the other. But that's kind of flexible. I can now just from the shack, 4-to-1, 1-to-1, 4-to-1. So, yeah, that's it.
Thank you so much. Thank you so much. Okay, Sorin, you're up. Ben, has there already been any questions on Zoom? I keep forgetting to ask. Okay, if anybody on Zoom.
There was one from Elliot for Connie from earlier. So while Sorin sets up, we can take that. Will you do a stream deck next year?
A stream deck, interesting idea. I'll put it on the list. Thanks for the suggestion, Elliot.
Mikko, will the designs for the balun be open sourced? Is the question from the answer is yes. I guess email Mikko or find him on RF if you need access to that.
All right. Thanks everyone. I'm going to talk quickly, and I maybe should start a timer so I know where we are. But all right, thank you. I want to be quick. I mentioned this last time towards the meeting. It's a project that Shri suggested, and I was very excited in following and trying to implement that. I worked a couple of weeks. I think it was December or January. So what is CW bot? It's a Discord bot that will read all the messages posted on our PAARA Discord, and then it's gonna play them back as Morse code audio into the audio channel that we have a single channel. Everyone is muted there except for the bot who can speak back to everyone. It will do by default 18 words per minute with 13 words per minute Farnsworth effective speed, and it will do it in a 650 hertz tone At the end of the message, it will send break, and it will then choose a different tone. The workings of it are pretty simple. It joins the audio channel, and then if any other user then joins the channel, it will greet them with your call sign, because we have nicknames with the call sign. So it will say good morning or good afternoon and your call sign, and you'll see an example. It also takes injects. You can inject messages into its own queue, and they end up at the top of the queue, not at the bottom, like after all the stuff has been written. And anybody on the server can control the speed of the bot. Like if you want to learn slow Morse code, you can take it down to 5 words per minute, and you can leave it there to echo back everything that's been sent. As I was saying before, the personalized greetings are, this is one example, and that's kind of the full message that you would see in there. A bit of initially it kind of sounded quite blunt. So it was all Shri's suggestions that made it polished as you see it today, and some of were mine in the interface thing. But we are trying to cut some of the beginning and the ending of the deeds and dots and the does just to make them sound a little bit better to the ear. And we choose a random frequency for the different messages, so that you kind of know when one stopped and another one started, it's going to have a different tone. Nothing uses disk. Like initially there was some prototyping where things were being written as waves, and then those waves were converted to Discord's audio. Now everything is done in memory. When the bot has been quiet for at least 10 minutes, when the first message comes in, it's going to send a VVV and then a message just to warm things up, which we would do in normally. This is how you control the bot. You go to the text channel called CW bot, and there you type /CW help, and the bot will respond back with all its available commands, and you can see them listed here. One of them, which is useful, is CW status. It's going to tell you what message is playing at the moment. So if you didn't catch it from the beginning, if you go and listen, then you can hear it there. You can see what's the message. It will tell you what's the active configuration, when it started, as in when the bot connect or booted up, let's say, and how much time has it spent transmitting. If you see there, it transmitted for 18 hours over a period of, I don't know how much, but it's only 10% of the uptime. So after about 20 days, it had sent about a day worth of Morse code to whomever was listening or not. It doesn't care. It doesn't judge. You can also look at the queue. Like when there's many messages exchanged between different people, the queue goes longer, and the queue can persist for hours, right? If it's like 18 words per minute at 13 Farnsworth and there's a lot of text, it will keep saying stuff. And as I said, you can see which channel it picked it from. You can see all these details here. There is Christopher exchanging some messages with maybe somebody in the room, right? So there's just a few commands that you might want to use, right? You can, if you want to change the speed, if you want to inject a message and you want it heard back, and then you can also clear the queue and stop. Clear the queue means leave the message running, the current one that's still transmitting. Stop means stop. It's gonna erase also the one that's running. If you change the speed, it will not change it on the running message. So because that's been pre-calculated and kind of computed, so it will only do it from the next message onwards. I want everyone to feel like it's their bot, like play with it. Like people, like I think the launch of it was a bit kind of not very public, so it kind of showed up there. Like in the beginning, wasn't even connecting. The bot joined the Discord, but wasn't saying anything. Then it came online, and people didn't know what to do with it. So we thought maybe people want to discover, but not many people wanted to discover. So here's how it works. Go break it. And I want to do a live demo for about a minute or less. But this is where the server, where the bot lives, right? This is a Raspberry Pi 5 on my windowsill inside the house, not outside. It's plugged in the wall on a 5-volt charger, and it's running fine. I mean, there's almost no CPU spent on doing that. So, let's do. I don't know how to. Yeah, Andy. Yeah, I want to do a demo, but the problem is that if I'm connected and then I don't know how I can just share my audio without sharing the Zoom audio. Will it share the audio as well? Okay. I'm concerned that if I increase my, okay, let's see if you can hear me through there, as if I'm from Zoom, that would be useful.
Yeah, you just unmute yourself and share your screen. You can do it. Remove this from Zoom.
But nobody will see me there. The thing was maybe for them to see both. Where is that one? Okay.
Share screen.
You see, that's the problem. If I unmute myself, it's gonna cause feedback.
Yeah, figure it out.
Okay, well. Okay, let me, I stopped. So if when I share, I can choose audio. Where the hell is audio? Okay. Share sound, okay. Okay, hopefully it works. So do you see, oh my God. Do you see my screen? All right, so we are on Discord. This is I'm connected to the CW bot text channel, and I type the command CW status. It says now playing non, and I am going to just join the audio channel. So one thing, the other one thing I want to try is just to change the speed so you can see how it is, and then we'll post a message somewhere else. We'll do an inject. I don't understand the question. Well, you just click it. There is a disconnect here at the bottom. Okay, so I changed the speed to 30 words per minute, and I'm gonna do a CW inject. Did I mute anything here? Hi, I'm not disconnected. I went a bit faster just to get anyway. So after 1 hour of after somebody changes anything, it goes back to the default. So if those are some same defaults, 18 words per minute with 13 funds worth, they will go back there. If we decide that people want different defaults, we can change them and they can become anything else. So thank you, and maybe Shri wants to add a few words.
Yeah, I have been using this to try to learn CW osmotically. The number of times when somebody would post something on the PAARA Discord and I'll alert up and start listening to it. It's been fun.
I was wondering why there's so many messages, but it seems that Ben has injected a few. And all right, any questions? Yeah, if you want to join Discord, there is QR codes at the back and on the side next to the coffee, and any paragraphs as well. And just something that Margaret mentioned before, there's a lot of there's a, there is a homebrew channel on Discord where a bunch of our members present here are talking all the time about various projects. So if you are into homebrew, that's a very good place to be. So with that, any other questions? Yes.
Yes. So you mentioned, I think, doing some sort of decay to get rid of a clicking sound. And I was wondering if that type of decay happens organically in transmitting CW out of a radio, or whether it's an improvement that could happen.
I'll let Shri take this.
Yeah, no, any good radio would do that. They would shape the envelope, both the click on, the click off. And if they don't do that, that's the reason why you have the T in the RST. If you're either this hum in the tone, or your key clicks are bad and so forth. But any good radio should shape the clicks on and off properly. It's the same thing that this is doing here in software.
Next question.
Well, I think we just saw a really great demonstration of the need for some sort of spam protection or
No, I think that works as intended. You can go clear the queue. Anybody can clear. There's no admin there. I specifically wanted anybody to be able to enjoy it. I mean, we don't have any. Yeah, go ahead.
Well, my question was going to be, did you build in any sort of prevention for abuse? And the answer is no. I would like to propose one small change you could make in order to prevent the majority of abuse, and that would be to ignore commands from Shri and myself.
That message was brought to you by the creator of the Unhinged Rants channel.
So there's two things there. One of them is that the bot specifically ignores anything on the CW bot text channel. It does not, like people who try to see things there, they would not be triggering the bot. And also the unhinged rants, is ignored by the bot currently.
So there are a few Easter eggs in there to make it interesting. And there are a few more that will be coming that does involve the unhinged rants. You can make guesses as to what it might be and see if it comes true.
Now everything is clean. Any other? And by the way, the code is not yet public, but I intend to make it public. It's in a Git private repository, but it will make its way eventually to the PAARA org. Any other questions?
This is more of a suggestion than a question. But I think you should have like a time limit. So if like you're not using the bot, like you're just on it for like hours, I think it should self turn off, because
Yeah,
you
so
accidentally leave it on in the middle of the night, you get a CW thing.
thank you. That's a good suggestion. And Shri was the only customer that was keeping his phone running and hearing messages but so initially I'm burning too much time here. Anyway, I'm spoken for you. One last thing, and then I don't know if we have any more time, but I did initially let the bot be connected all the time, and then when there was a message, it would just send it, and then we ended up with some random crashes. It seems that the connection was getting disconnected. There was a bug in the library I was using, and I was getting crashes. So now, after a bunch of minutes of timeout, it will disconnect and go back cleanly, and then it will reconnect when there's a message to be sent. So that's how we got rid of that. Thank you all very much. And
so Justin had put out a poll saying, when did you all start working on your homebrew project, and when did you finish? I apologize that my answers to your questions were absolutely false. Next year, when I answered that question, I would say I've been working on it for a year. And this year, my answer to the question is I thought about this project to demonstrate 25 minutes after Homebrew Night had started. So in other words, the thing that I tried to present today couldn't get it working perfectly fine. We learned a whole bunch of stuff. There's more to do, so it's postponed for another day. But instead, I'll use the time to show something else. Well, yeah, I've been working on it for a while, but the idea of using that as a substitute came through in the middle of the meeting here. Okay, so long big URL. I just have it canned ready just so that I can show you something interesting. Much of this was inspired actually by Mikko's talk on about the ionosphere and how it's not what you think it is. It's absolutely not what you think it is. For example, we all learned that light travels in a straight line. Nope, not in the ionosphere. So this is a simulation of what happens in the ionosphere, completely running in your browser. People who are familiar with VOA CAP or the ITU HF CAP propagation reporter program, simulation program, those are used typically to predict what propagation conditions would be like. This is the opposite of it. It's post-diction, if you want to call it that. It's like you've already made a contact and you want to know how your contact actually went there. And it turns out that it's not a straight line. So it's kind of like, you can think of it like ADS-B for your QSO, right? You know, which way your plane went, you can figure it out. Or it's kind of like Strava for shortwave, right? Which way your propagation conditions were at that time. So first what I pulled up here is a relatively simple example. The thing looks like a curve because this is a Mercator projection. So the great circle map looks like a curve. But if you look at it in the azimuthal projection, your radio wave is a straight line. Out in the center is your transmitter. And the signal is powerful enough that it went all the way to the antipode on the other side of the Earth. It's just relatively straightforward. But the same, let's look at the same. So, okay, let me explain a few things. So I put the transmitter location at where we are right now, approximately. The sliders here you can use to adjust the latitude and the longitude. And let me move that and move it like as close as I can get to where we are, not just for the, just to show that it can be done. And it's all completely running in your browser. So once it loads up, it's all within the browser. It uses a very simplified model just so that it can run with good performance. Yeah, I'm coming to that. Exactly. Yeah, perfect. So all the dots that you see, the colors, I'm still tweaking the colors. I'll make them a little bit more M&M-like to have more contrasting colors. But right now there are a bunch of blues and purples and browns. They're kind of close. I need to tweak the colors a little bit more. But each one of those colors indicate what the radio wave suffered through or benefited from along the way. Right? The density of dots is proportional to the signal strength. And the ratio of the different colors tells you whether this particular signal traveled first class or economy or was double booked and had to be bumped off the flight, right? So by looking at the colors, you know roughly what happened. But let me show you something interesting. So the same transmitter location now, but I'm picking one of the signals that went out here. And you notice that there are these A's right in the equator region. That represents those are the Appleton anomalies, where the signal that's coming in hits a fountain of ions that are floating around in the ionosphere. And the fountain is being caused by the heat of the sun, literally causing winds in the ionosphere, the same way that we have winds in the troposphere. There's winds in the ionosphere as well. And that fountain of ions results in like two large accumulations of ions on the two sides of the equator. So any radio wave going through that bounces straight off of that. So so here you have a signal where it hit this point, this Appleton anomaly, and most of the signal strength just went off in this direction, right? Completely perpendicularly off. And there's another path which was completely in a different bearing that came by here, and that then resulted in another wave falling in this area. So the point is that it's not, so no matter how much you try to get your antenna bearing, high gain antenna pointing the right way and so on, that's not what the ionosphere is doing. It did something else. So the other day, I think last month, Rob was reporting that he was making some contacts in HF, and for some odd reason, everybody who replied to him was from Mississippi. Right. So, so mentioned to Rob, give me the exact time, date, and frequency of the QSOs that you made. Send me your logbook or whatever. We'll feed it into this and find out why Mississippi was being very favored that day. Like there were some discount tickets available, and all your radio waves were going in that path. If you as you hover on these, the sidebar on the side opens up, and it shows you what's happening. So this green thing, for example, is a reflection from the F layer. And then there's another interesting thing that's happening here. That's a caudal duct, which is where the radio wave goes, hits the F layer, and then comes down and hits the E layer instead of coming down all the way, goes right back up again. So it's taking shortcuts right through the ionosphere. And then all of a sudden, instead of losing a lot of signal strength each hop, it's effectively getting from end to end without any loss whatsoever. So you get this very surprising QSOs, and why your QSOs were surprising, or why your QSOs didn't work surprisingly. This is a tool that you should be able to check with that. Eventually, my plan is to pull data real time from PSK Reporter or from logs that you could upload, and then give you a KML file that you can put into Google Earth, and you can see which way your waves went up and down. So that's all I have for today.
This is really neat, Shri. So how much of what we are looking at right now is real data versus simulated data?
Everything is simulated in the way it's running. However, the simulations are based on the input parameters that you give here. So that's a great question. I should call them out. So,
but right. So let me just, in interest of time, let me just clarify my question. So you say we've got a couple of Appleton anomalies here. Were those real, or is that part of the simulation? So is the base data real, or is that simulated?
Yeah, the anomalies are being simulated. Okay. Because I don't have source of real-time data of that.
Okay, so you're saying in the future you're going to pull real data.
Yeah, I'll explain. It's not very long. So what I'm in this simulation right now, what I'm demoing here, the time of the day, the season, the year, and the sunspot number is all being set by these sliders. However, the sunspot number I'm planning to fetch real time. And when you change the date to any date in the past, we'll get the historical data of what the sunspot was on that day. Then based on the sunspot numbers on that day and the KP index and the G index and the X-ray index, the simulation would run and then tell you what the anomalies were. So the anomalies of the path, they are being calculated from the simulation. However, the underlying space weather, the underlying input from the sun that is causing those anomalies can be fetched from actual historical data.
So you wouldn't be getting data about the anomalies. You would be inferring the anomalies.
Correct.
So you're getting the real data about the sunspot numbers. You're looking at the paths, and then you're saying, aha, from the paths. From real QSOs, we can infer anomalies in the ionosphere.
No, but that's an interesting idea. That could be done to further validate. At the moment, it's only doing the forward path. From the sunspot numbers and the weather condition and the tilt of the Earth, it computes where the anomalies would be.
Got it. Yeah.
But then I could go back to PSK Reporter and validate to see if that's right, and then close the loop. So that could be done.
So this is really interesting work and a very nice graphical representation. This is very interesting work and a fascinating graphical representation. Is this a frequency range or a frequency band? And why are there so many points away from people like South America and Africa? It doesn't look like a typical MUF map, for example. It's a very unusual pattern, or a little gray line, but.
Yeah, it depends on the right now it's simulating for 14 megahertz with 100-watt power.
20 meters.
20 meters, 100-watt power, and close to morning from here, right? So
Oh, that is gray line. Okay. So
correct, right? So
there's sunrise.
correct, yeah. In fact, if you click here on the paths here, and I have to choose the fiddle with the time a little bit to make a perfect example, you'll actually be able to see the gray line anomaly happen also, where as it skirts along the gray line, the signal gets a 50 dB boost and also bounces off in a different direction to hug the gray line. That does get simulated here. To your first question, I'm covering all of the HF bands. And also going all the way down to 100 kilohertz LF and 144 megahertz VHF. But the model is really very faithful only for HF. The rest are a little bit of an extrapolation based on that. Sorry, I didn't get the last.
No, I mean, I was going to suggest looking at Whisper or PSK reporter data historically, right? You can go back and pull the historical data. You can then ground truth your historical models based on those, for example.
Correct, absolutely.
Which you got to yourself. That was
absolutely, yes, yeah. So time is just a number. If for real time now we can predict and estimate, but for the past we can get historical data and correlate. Yeah, that's a good point.
Thank you, Shri. Paul, you're up. We got to go to the next one. Sorry. Yes, we can.
Give me the mic. Okay. There's an awful lot of new people here, and I hope you guys are inspired. This close enough? Okay. There's a lot of new people in this room, and I hope you guys are inspired because I've been at this since I was in high school, and there's still new things. So, welcome. I'm going to discuss an HF antenna, and the first that I made for some portable operation. Hello? Okay. At some point, I'm going to need two hands, so we'll just. Okay. And there's no antenna tuner because I want to operate portable, and that's just one more contraption to have to deal with is having an antenna tuner. And many of you helped went to PacificCon, and I sat near the front when N6BT was talking this last time, and he said, if you put up a vertical antenna, how many radials do you need? And the answer was, if they're off the ground, you can get by with one. Radiation pattern would be a little lopsided. So that was sort of the inspiration. And then a little more time went by, and I realized I got to get going. I'll explain at the end why there's a time fuse on this. But there's a group of people, some in this room, who like to go out to the Baylands from time to time and operate QRP. So I've been hanging around with them for a while. And I'd ordered some stuff. I'd ordered some stuff long before we had a tariff problem, and actually I was able to find it in my garage. Isn't that almost a miracle? Okay, Connie's going to be my mic. Okay, I got to bring a couple things over. So I got a tripod, and the other thing I found was a 20-foot fishing pole. Oh. And I am not going to put this up in this room. It probably wouldn't radiate too well from inside.
He says as he puts it up in the room.
Well, I'm not going to pull it. So a couple blocks of wood so I can mount the fishing pole. And it will go up, but that's enough for the demonstration purposes. And then so I made blocks of wood to hold it. There we go. And then I had my original plan is I got a balun off of eBay for about $15, coax on one side, binding posts on the other. I don't know what's wrong with that balun. It turns out to be more lost than transmission. I'm waiting for a week with rainy weather so I can stay indoors. I've got a lot of balun experiments I want to do, but the weather has not been cooperating. But this little panel with an SMA connector and a couple of binding posts was left from another project. So that's kind of the core of it. And then the idea was, okay, I can run a vertical wire up and I can run a radial over. And the next thing I realized after spending an evening with EasyNet trying to figure out dimensions, I looked at this thing and I said, how am I going to attach the vertical wire? Realized to be mechanically much easier if I use these little rings. It's a fishing pole. So that meant the vertical length is not by some formula that we all memorized to pass our ham ticket. Is that question still in the pool? Anyway, it's the spacing between the rings. And I got to that point, and it was one of those days to go operating, so no time for calculations. We're ham. So I went out and I pulled it up some distance and put a wire on, and I ran a wire out to the side, and I spent a lot of time with an nano VNA. The VNA description will be next month's lecture or something, or the next several months. But okay, and I finally fussed around and I got it to get a resonance with a low SWR on 20 meters. Okay, that's great. Now, what about 17 meters? Well, all I should have to do is shorten the radial. And after some fussing around, I got that. And by that time, it was getting late in the day. Says, okay, we've got a concept here. But over the next several sessions, I discovered that things were not as repeatable as I'd hoped. I'd hoped I'd have maybe 2 or 3 different lengths of vertical wire and a long and a short horizontal wire. And I just kind of bunch up the wire or something to get the right length, but that was totally not repeatable. I tried coiling it up around my hand, putting it over the end of the wire, and yeah, a guy stake. This one survived numerous field days with other antennas, so it's an experienced part of this project. But that's what I just jam this in the ground, and then if I coil the wire up and drop it over, okay, that'll work. And I found sometimes I've made the wire shorter, but the frequency was going down. I think I made a loading coil here. So much fussing here. Oh, well, what if I fold it back? And that turned out to be a bit of a bother. Because the wire is kind of soft. But I did, there's my coax. There's the choke balun, not very sophisticated, but it seems to work. And there are these little toggle things that I could slide on the wires. And I said, okay, these little toggle things. That's another one of those miracles. I bought these 10 years ago. And golly gee, it took me about 5 minutes to actually find them where I'd left them. That never happens to me. I don't know how that is. Thank you. Somebody was looking out for me. But if I tried doubling back 3 or 5 feet of wire, I still wasn't getting good results. And maybe there was loading. And about that time, I realized, well, this one combination and this one radial that's all the way out works on 15 meters. And from that, I got going, oh, rather than adjusting the wire, let's make a bunch of wires. And somewhere along the way, this was a couple of weeks ago, and Connie comes along and she says, yeah, and then you have recipe cards. That was it. I have recipe cards, how to set this together. But this idea of maybe just make the wires the right length. So after a bit of fussing around, a week ago, I finally got to the point where I was actually starting to use the transmitter instead of the VNA. And today I went out and the VNA never got out of the car. I just put the radio on. SWR is better, 1.5 or better across all the bands. And I was going to say there was no computers involved, but I was using the reverse beacon network, which reported was hearing me. There didn't seem to be a lot of contacts going on, but I did work at JA on 15 meters this afternoon. And so what I wound up with was several sets of wires, one vertical wire and several horizontal wires. And when I finally had time to think about it, it's like I have a dipole. One's vertical, the other leg is horizontal. If it comes to pass that they're about the right length, we get pretty close to 50 ohms. And if it comes to pass that one's longer and one's shorter, well, it's a dipole not fed near the center. So we're getting, the SWR would go up. But I was able to get it so I could tune 3 bands. So let's see, this set of wires will tune 21, 24, and 28 megahertz. I put one up, one vertical one up, and all I have to do is change the wire going off to the side, and a couple minutes later, I'm on the other band. Just check the SWR, and why is it infinite? Oh, because I disconnected the coax process. So that's the history of this. And the reason I have some under time pressure is a week from now, if I'm going to be putting this in my car and making sure I've got all the pieces and double checking, because in a couple days after, so it's like a week from Monday, I will be in Joshua Tree National Park doing a POTA. So I'm going to be there on a guided hiking thing, but I've been with this outfitter before, and usually somewhere around 3 o'clock in the afternoon, give or take, we wind up with nothing, read a book or relax or whatever. No, I'm not going to relax. So I can operate on any band from, 20, 17, 15, 12, 10 with this antenna, and roughly 3 to 5 in the afternoon, Monday, Tuesday, Wednesday, a week and a half from now. So I hope to hear about you guys. Mostly CW. I'll take the mic just for fun, but mostly CW. Questions?
You had a question, Keith?
Fishing pole height.
It's about 20 feet. I thought briefly after I got this far, could I do 30 meters? The top is 20 feet. The one going out would have to be 25, 30 feet, which is good. Yeah, okay, let's just keep it practical. No more questions? In the back, it's got a question.
Hang on. Wait for the microphone. Sorry.
I copied like to work.
I'd like to work you.
Okay.
Are you going to spot yourself on the POTA.app site?
Well, I have no idea if there's even going to be cell phone there.
Where's Starlink?
I don't have a Starlink. I've got an ICOM radio, a ham radio.
If you do the POTA activation,
Yeah.
You'll get spotted in the Discord. So
Right.
the Discord will tell you.
And then it'll go from there. Or at least if you see my call sign pop up on the reverse beacon network, that'd be a good clue. If somebody like Connie is paying attention.
Yeah, so Paul and I have actually discussed exactly that point, and I have him in my calendar, and I'm going to be watching the reverse beacon network and
Right.
of course spinning the dial.
Right.
If I see you, I will spot you.
Good.
Yeah.
Yeah.
So hopefully, yes, but
Yeah.
depends on a lot of things.
Yeah, well, I was able to get reverse beacon spots on all bands this afternoon, even though the bands seem pretty quiet.
And he's doing that with a straight key, by the way. He gets spotted on the RBN with a straight key.
Well, part of that I discussed with Connie is I don't yet have one of her button boxes. And with a straight key, I can change the speed instantly. I don't have to stick down in the menu and fumble around.
I mean, just
Go
there's
ahead.
some really cool tools for that specific use case. So, I mean, one is that I do activations for POTA. If you post an alert, does that reflect to RBN? If you get, so I know for someone's on the air, if you post an alert, it'll pick you up on RBN and it'll automatically spot you.
Uh-huh.
And there's some cool apps which you don't necessarily need a KX2, which is how they started, but Sodomate will generate audio FT8 tones for you, and you just synchronize it, and you can just hold your microphone up to it, and it'll put an FT8. You have a million options.
Why would I want to use FT8 when I can use CW?
No, no, no.
I mean, I got to take
No,
a
it's
picture of a bunch
it's
of
it's a
stuff.
well. I mean,
Yeah.
fair enough. But it's a great way to get an off-grid spot. You just hold your phone up, you get the FW8, the FT8 spot. It goes out with your call sign, and there's like
Right.
31 bits of information you can send.
Okay. Oh, just send that as a spotting signal.
And then it automatically posts it. It's just a reflector. It takes that spot and posts it with your
Okay.
information.
Okay. After during the break, let's chat. So I've got all the details. Okay. Last question.
Yes, so, sorry, talking about the, wow, this is loud. Talking about the spotting yourself from with RBN, if you do schedule your activation on the POTA website, then they will know you're there. I guess, I hope I'm not repeating what Tony said, but
So
you can just put the days where you're going to be there and it's going to pick you up.
So what I just told you about the days, I put that on the POTA website in some specific fashion, and then the POTA network will see the RBN, and away we go. Yeah, well, our RBN will be doing its thing, and the POTA website, and together they'll. Okay.
Thank you, Paul. Thank you, Paul. Okay, next up is Masa. He's on Zoom, so if we'll let you share when you're ready, Zoom, and or Masa, go ahead and introduce yourself.
Okay, let's see. Well, you can see me okay, right? Oops.
Yes, we can see you.
Okay, so I'm gonna let's share my desktop. Let's see. Okay. Let's see. So today I'd like to talk about my quest for a small portable HF antenna. And it's actually a multi-turn loop antenna. And before we jump into this topic, I really like to talk about recap from last year. You know, I talked about convertible bass guitar, electric bass guitar. And this is the one actually I'm talking about. Some of you might remember. And I actually learned that there's the famous the guitar shop in LA. It's actually called Norman's Rare Guitars. So I just have opinion from him. Norman, he's actually quite famous, I think. And he's actually the guitar trader. He's not a guitar builder. So he really didn't give me any particular comment on my experiment, but he told me that the Gibson EB-1, that the first Gibson guitar was actually you can put the stick so that you can play in a stand-up position. So this is the first Gibson electric bass guitar, and you see that there's the bottom there's a pins, but you can take it out and you can actually put this a black pole so that you can play in a stand-up position. And I thought that's kind of interesting. I mean, it's Gibson did this thing a long time ago, and yeah, this is a flyer of the Gibson. Just give you the idea. And strangely, I have a credit violin bass. I have this guitar, so I could do this. I haven't. This is just a fake photo. I haven't attached this pole yet, but actually I might try. So that's the story for the recap for the last year's let's see, homebrew. So this year, I like to talk about this my quest, and just like to talk about where this idea came from. And I wanted to have a small antenna, small portable antenna, which could be used in HF, and especially now that we are, solar cycle 25. And I actually get a lot of information about small magnetic loop antenna. It's interesting, but it's actually, I think it's very complicated. You have to use a high voltage capacitor, variable capacitor, and also the setup is kind of heavy. So I wanted to try this in a much easier, much simpler fashion. And I thought of maybe, I could create a multi-turn small loop antenna. And I don't know exactly how I got this idea, but just came to me. And obviously, antenna like this, low radiation impedance is a problem. But if I use voltage feeding instead of current feeding, I might be able to, solve this problem. So that's how I got the antenna. So the first, I actually, look into the past research or study, and I came across the paper by this T.L. Flake, Ohio State University, and it's not exactly what I actually had in my mind. It's not a wire antenna. It's actually a more solid, antenna. But just gave me enough courage to actually start this adventure. So my attitude was that to build many prototypes, and I just try to figure out how the antenna behaves, and so just figure out this formula empirically, instead of actually theoretically determining it, and hopefully I can actually build antenna, for the HF, ham, radio band. So that's actually this whole thing. It's actually started. And just to give you the idea, this is experimental antenna. This is many turn loop antenna as you see, and you see this. This is a choke, a coaxial cable balance. It's actually choke balance that makes sure that because coaxial cable is unbalanced. So, but then this antenna itself is balanced. So I have to convert from unbalanced to this balance, and I basically use a choke cord. And right hand side, this is a measurement setup. I have a luxury to use a network analyzer at work. So I just hang the antenna and just measure the impedance. And let's see. Okay, so I'm gonna just stop here. Then let me show you the test result. Okay, which is right here. This one? Yeah. So the first one actually tried this 87.9 millimeter right here is a diameter of the antenna. And if you actually look at it, wire length is 282 centimeter, and turns 10. Diameter is 87.9. And when I measured it, okay, the first resonance is 24.83 megahertz. Impedance is 686 ohm. And so on. So I actually changed the length, turns, and eventually when I actually came to 7 turns, I actually hit the sweet spot, which is second resonance is 121.2 megahertz, and the impedance is 48. So okay, this is usable, right? And so I actually continued this, basically experiment to find the magic formula. That's what I actually tried to do. I tried 74.5 millimeter diameter, no luck. Move to 99, no luck. Actually, also I changed the spacing too. Instead of just wire next to each other, I actually create a gap and see how I think that affect. And I tried 81 millimeter. So, no success. And when I actually came to this particular combination, 11 turns, this is interesting. This is actually a dual band. The first resonance is 90.7 megahertz and impedance is 46. The second resonance is 162.6 megahertz and 48 ohms. So, unfortunately, they are not ham band, so we cannot use it. But actually, it seems to work in a dual frequencies. And obviously I actually wanted to make it to HF band, so I actually built a big one, and I'm going to show you the photos of these this different diameter stuff. After this, this particular one diameter is 455 millimeter, and let's see, wire length it's quite long actually. This is 14.29 meter, and turns 10 turns. Diameter is 44, actually 45.5 centimeter. And the first resonance is 20 megahertz. And, this is 50 ohm. That's usable. But, okay. So now let me show you the photo first. That's actually more interesting. Let's see. This one? No. Sorry. Let's see which one. Yeah. No.
Hey, Masa, just to let you know, your time is starting to run out. So maybe
okay.
to the
Okay. So, yeah. All right. So let's just go back to, okay. Let's just go back to a test result. Then I'm sorry. How much time do I have?
I was giving you about 8 minutes, and we're coming up to 10.
Okay. All right. All right. So, wanted to build antenna usually in a hand band, but I could not find a usable hook to do it. So, to overcome this problem, I actually looked into a simulation software, and I actually tried EasyNC, program. However, this software is actually not really easy to use. And at the last result, actually I tried ChatGPT, and to my surprise, it was the best decision because I was actually blown away. It's very smart. It's like working with renowned antenna specialist or whatever. Just yeah, I'm it's too long to share with you today, but I learned a great deal. So okay, so since I'm running out my time, for conclusion, was it success or failure? It depends on how you look at it. If, could be failure because I could not build a usable antenna for the handbands. It could be a success. I learned a great deal. And more importantly, I really have a lot of fun doing it. And I'm actually, since I tried with ChatGPT and, it can analyze antenna. It's based on my actually, the data. So I might be able to actually build it. So that's where I am. Yeah, that's all. Thank you.
All right, you're getting a lot of claps here. Very impressive. Was there any quick questions in the room on his build there? Okay, we've got
Hey, this is really great. AI saved the day for you. And
yeah, kind of like
maybe I should go to AI so I can finish my RDF project.
Yeah, I'm totally blown away. And also I'm kind of scared actually. It's not that it's quite possible that someday very soon that you dumb human just do what I say. I think that's coming. Really, it's
Hi,
well,
this is Connie, W6CFI. How long from the time you thought about this project to this point?
Actually, I worked probably last year. Good 6, maybe, let's see, 4 months, about 4 months, and I kind of gave up, because this simulation software didn't work. I basically ran out of my options. Then I tried a chat GPT actually a few days ago, and it just blew me away. Really, it's actually unbelievable. It's so I hope I could actually tell you something wonderful next time. Would you like to see the photo? Just quickly show you the photo of the antennas I built. I could
go
do
ahead,
that.
put the photo up real quick.
Yep. Okay, let's see. Oh, you know what? It should be behind this. Okay, so these are the antenna that I built, tried, so I can go on. Different diameters, different turns, and it's actually putting a tape around it so that I can actually increase the diameter, and I try to find a formula. And so all kinds of stuff. This is a dual bundle, by the way. And this is a 20-meter one. It's not that big. It's actually light. Because the styrofoam and just wires around it. So I wish to actually make something that's usable for lecture. That's it.
Okay. Thank you so much, Masa.
Thank you.
All right. I think that's it. All right, everybody. I was hoping 9 o'clock, but I figured we'd run late anyway. That's why I can only keep it to about 10 people. So that's why it's quick and down. But you know what? You guys did a great job. And I know I learned a lot. I hope you did too. We'll do it again. Pair in the Park. We do that twice a year. Bring your projects to Pair in the Park, and you can spend the whole day talking about your projects there as well. So thanks again for that. I think that's it from this then. I'll throw it over to you.